Hi, my name is Julio Casal, and in this video I will show you how to prepare a continuous integration build using Visual Studio 2010, Team Foundation Server 2010, and Team Build 2010. Remember, we are using Beta 2 of all these products. So, now that you have coded and tested your product, like this bookstore application we prepared, and you must make sure that you do have something to show to your customers all the time. And this can be difficult when your team is made up of more than one developer, as any developer can potentially introduce new bugs at any time into your product cycle. So to avoid this, there's this methodology or good practice, more like that, that we call continuous integration, where each time a developer checks in some code, a new build is performed in some other machine that is not really any developer machine. Okay, so let's see how this works. Let's go to Visual Studio 2010. Okay, and this time let's log in as the project manager. This is because we will need some additional permissions that a developer doesn't have in order to create a new build definition. Let's close this. Okay, let's load the solution, the bookstore solution. Okay, so right now just loading, and it is here. Okay, so now let's go to Team Explorer, open the builds node, right click and select new build definition. This opens a new dialog in the main center of the screen where we need to enter some information. So this build definition will be called let's call it Bookstore Continuous Integration. And for description, this is the continuous integration build. Okay, now let's go to trigger. What will trigger this build will be a developer check-in. So we will select continuous integration, and as I said, that means that anytime a developer checks in some code, a new build will be performed into the server. So that means that the server will get all the source code from all the developer's machine, and it will start a new build, building all the DLLs, the assemblies in the application. There are some other options. As you can see, you can select a schedule if you want to prepare this build to be automatically executed. For example, each Monday, Tuesday, and every day in the week at 3 a.m. If you want to do this automatically, you can also select gated check-in. If you want, this is a new option in 2010, very interesting. If you want to actually, each developer checks in some code, but the code is not actually placed in the main source code, but it is actually shelved into a temporary location. A build is intended to be done, and if it can be done, the check-in is completed. If it cannot be done, the check-in is not allowed at all. So that actually prevents more any developer from introducing new bugs into the application. For this example, we will just use continuous integration, so that at least will alert us if any developer breaks the build at any time. Let's go to workspace. We will just use the defaults for this. Let's go to build defaults. Here you must select the build controller. This is the actual build machine. As I said, this is another machine, not any developer machine, a server, where the build will be performed. And you can also have and configure in your Team Foundation server if you want to have more than one machine, like agents, if you want to somehow distribute the build effort among more than one server. Here you must also specify the build output directory. So this is just some network share anywhere in your network where the Team Foundation service account has write permissions. I have already prepared a directory for this in Team Foundation server. You can see here DFS build output, and we will just use this directory for building the application. Okay, let's copy this and paste it here. So now that we have this, let's go to process. In process, you can specify some other options, like for example, what do you actually want to build? So for example, here you can specify which would be the platform and configuration that you want to build. So you can select from among the different platforms and different possible configurations. Or you can just use defaults, as we will do right now. You can specify which is the project or solution to build, and you can also specify if you want to run all the tests into the build. So this means that any unit test and any other automated test that your testing team prepared for this solution can also be run into the build. So this means that even if a developer doesn't actually break the build, he might prevent a test to run. And if this happens, this is also not good, and that can also stop the build and alert any person in the team that this is happening, okay, which is very useful. You can also specify the build format. This means that you can specify how will each folder into your build server be named for each of the builds. Like, for example, the default one specifies that it will use the build definition name, bookstore CI. It will use the year, then the month, and then the day. And finally, build revision if you do more than one in a single day. You can also use some macros here if you want to specify a totally different format string for the build name. Okay, if we go to retention policy, you can specify how much time you want to keep these builds into your server. So this means that, for example, for failed builds, you can say, hey, I don't want to keep the 10 latest builds. I want just to keep to maybe 5 latest builds because I don't really care about failed builds. Okay, so let's save this. You can see the new build definition is right here. I can right click, select Q new build, and from here I can just manually trigger a build. But as this is a continuous integration build, I will prefer to do this from a developer trigger, a developer changing some source code and triggering the build. So I will just cancel this, exit Visual Studio, and let's go to Visual Studio once again. This time, logging into Team Foundation Server as a developer. So let's log in as a developer. Let's open the solution. And what we're going to do right now is just a very small, very simple change to the source code, and then check it in, just to make sure that the build is actually triggering. So let's open the business project, the book class, and let's enter some comment here. This is the book type. Let's close this. Let's build the solution. Make sure that we're actually checking in some buildable code. Okay, it's good. Let's check in. For checking in, we should always select a work item associated. Let's select the build the book list screen, which is the appropriate one. Check in. So as soon as the check-in finishes, Team Build detects this check-in and will trigger a new build. So if we double click in bookstore.ci, any developer can see the status of a build for sure. We can go to the queued builds, and you can see that the developer just triggered a new build at 5:33, which is right now. Okay, let's double click this, and you can see in this screen, you can see the status of the build, okay, as it is performed. You can see the current time right now, the running time. You can see what is Team Build actually doing. It just got the build, updated the drop location, okay, updated the build number, okay, initialized it, okay, initialized the sources, initialized the workspace, added a new label, which is also very useful, a new label for this build. It is trying to compile, test, and associate change sets. So first, let's compile. Okay, it is compiling. Okay. Then it is actually trying to perform all the tests, the unit tests. We have 2 unit tests in this solution, and later it will try to associate any change sets and work items for this. Okay, so you can say, for example, this task and this source code is associated to this new build. Okay, it's very good for tracking. Okay. Okay, so it just finished, and the new build is complete. You see all tests passed and everything